Functions and their domain. Okay, in this video lecture, our objective is to focus on the domains of functions. We want to determine the domain of a given function. All right, we know two things that are going to be applicable for this video lecture. The first thing we know is what a function is. Okay, a function is a relation that associates each element of the domain, each input, each x value, with exactly one element of the range, the output, the y value. Okay? And the second thing we know is what the domain is. The domain is the set of all inputs or values for a function. Anything that can be put into the function and result in an output is a member of the domain. Okay? So, how do we find the domain? Let's just take a look at kind of the basic thinking behind it. Get my paper straight, I think. Okay, so define the domain of a given function. And we're going to be speaking only about, we're going to be talking in the real number system. We're not going to worry about the imaginary numbers. We're going to be focusing on the real number system. So basically, you always start with the domain being the set of all real numbers. And by the way, that looks like this. It's kind of a, some people write it with an R with two vertical lines like that. That's the set of all real numbers. So we're going to start there, and we're going to take away or recognize what we can take away from that set. Since the set of all real numbers is an infinite set, we're going to find out what is not going to be applicable to the domain. The first thing we look for is we're going to look for denominators. Does the function have a denominator? If it does, well, we know we can't divide by 0. So we want to exclude any numbers that will give us a 0 denominator. Okay? The second thing we're then going to look for is we're going to look for even radicals. Okay, even radicals are square roots, fourth roots, sixth roots, etc. Okay, because if the equation has an even radical, we know we can't have a negative inside the radical. Okay, so we want to exclude any numbers that cause the radicand, and the radicand is that expression that's inside the radical or under the radical. We want to exclude any of those numbers that cause the radicand to be negative. So my very beautiful drawing, you'll notice that I'm a very talented artist. Basically what this boils down to is keep a sharp eye out for even roots and denominators. That's where you want your focus to be, even roots and denominators. Let's take a look at 4 examples. Okay, first example, my paper straight, I think. Okay, we want to find the domain of each of the following functions. Our first function is defined as f of x, as the f function. It's defined as x squared plus 5x. Okay, no roots, no even roots, no radicals. So we can say, you know, I can put anything in here I want because squaring anything is fine. Multiplying it by 5 is fine. All real numbers this can happen to, and I'll get an output. Okay, so the domain here, the domain is all x's such that x is a subset of the real numbers. As long as x is a real number, then we're fine. Again, this vertical line means such that. This symbol is a subset of, and this symbol is a symbol for the all real numbers. All real numbers. Okay, example 2. I'm going to call this function the g function. let me give another line because I want to put a fraction in here. So we're going to call this one a g function just to kind of mix it up a little bit, because you do see different names for functions. And the g function in this case is a fraction or a rational function. Okay, so the g function says take the argument, find the product of the argument in 3, square the argument and subtract 4, and then divide the product by the difference, and you'll get the output. Okay, so here's my g function, 3x divided by x squared minus 4. Well, you'll notice here we have a denominator. We want to keep an eye out for even roots and denominators. And we know denominator tells us that we cannot have a zero denominator. So we know x squared minus 4 cannot equal 0. Okay, well, if we do the math here, add 4 to both sides, that means that x squared cannot equal 4. And this tells us that x cannot equal positive or negative 2. Okay, again, we take the square root of both sides. Don't forget you have 2 possibilities, a positive and a negative. All right, so our domain all x's such that x does not equal positive 2 or x does not equal negative 2. Anything else will work except for 2 and negative 2. And that's how it's written in set notation. Okay, example 3. I bet you know what's coming up next. We've done an example with no denominators and no even roots. We've done an example with the denominator. Can you guess what's going to come up next? All right, example 3. We're going to call this a different function h, and we'll use the letter t just to kind of mix up the fact that we can have different letters representing the input or the argument. H of t is the square root of 4 minus 3t. Okay, well, what do we have here? Keep an eye out. Denominators and even roots. This is a square root, so we have an even root. Okay, and what do we know? The radicand, what's underneath the radical, must be greater than or equal to 0. So 4 minus 3t must be greater than or equal to 0. Okay, let's do the math. I'm going to add 3t to both sides. So 4 greater than or equal to 3t. I'm going to divide both sides by t. So t less than or equal to 4/3. I'm going to rewrite it. T less than or equal to 4/3. Read from the variable side. I just switched it so that it's easier to read this way. So as long as t is less than or equal to 4/3, this is greater than or equal to 0. Okay, so my domain, all t's, excuse me, I used t, such that t is less than or equal to 4/3. Okay, so there's my domain for that one. The input must be less than or equal to 1 1/3, otherwise, in the real number system, this is not going to work. Okay, my final example. I'll move the paper up here a little bit. I think I have enough space for it. We're going to call this capital F of x, and that's fine, just a capital instead. And this is equal to, I'm going to combine them, the square root of 3x plus 12 divided by x minus 5. Okay, well, hang on a second. Here is an even root, and here is a denominator. I have to address both of these when I talk about my domain. The denominator is probably the easier one. Let's do it first. I know my denominator cannot be 0. So I'll label this my denominator. Okay, x minus 5 cannot equal 0, so x cannot equal 5. Okay, now let's address the even root. Okay, the radicand, the expression underneath or inside the radical, must be positive or 0, greater than or equal to 0. So 3x plus 12 must be greater than or equal to 0. Okay, I'll subtract 12 from both sides. 3x must be greater than or equal to negative 12. I'll divide both sides by 3 because I'm dividing by a positive. I don't change the direction of the inequality. X is greater than or equal to negative 4. Okay, so I have two restrictions. X can't be 5, and x must be greater than or equal to negative 4. Okay, so my domain. Okay, all x's such that x is greater than or equal to negative 4, comma, x cannot be 5. Okay, so there's domain. So again, with domains, you're keeping a sharp eye out. I'll go back to my beautiful drawing to recap. Keep a sharp eye out for even roots and denominators.